Today we will see the stationary perturbation theory for a degenerate case. Already we have seen it for a non-degenerate case. Today we will see it for the degenerate case. We have seen in the case of stationary perturbation theory, that is non-degenerate case. We have replaced h by h naught plus lambda h prime and psi naught psi by psi naught plus lambda psi 1 plus lambda square psi 2, and it will go up to n. And similarly, we have replaced e by e naught plus lambda e1 lambda squared e2 plus it will go up to n. So this psi we have replaced psi naught lambda psi 1 plus lambda squared psi 2, and we have grouped the term with lambda and lambda squared and so on. So this also we have discussed elaborately in the case of non-degenerate non-degenerate perturbation theory. So if you note the rectangular blue color box, you can equate the lambda term both side, right? That is both right hand side and left hand side. That is h naught pi 1 plus h prime psi naught is equal to e naught psi 1 plus e1 psi naught. Degeneracy means you know very well that you will have same energy for two different stage, two or more different state. Here we will consider the two state which are having the same energy level. It is called twofold degeneracy. Uh, we know from the first order perturbation theory, h naught psi 1 is plus h prime psi naught, which is equal to e naught psi 1 plus e1 psi naught. Just now we have seen. If you take inner product with psi of a, psi of a means let us say we have two states which are having same energy, that is psi of a and psi of b. Now you take the inner product with the psi of a with the left hand side and right hand side. You know about the first term in the right hand side and the left hand side. This will cancel out because both are same. This will cancel out. So you will be left with h prime psi naught e1 psi naught. In the left hand side you have psi a h prime psi naught. In the right hand side, since e1 is a constant, you can take it out. This will become psi a psi naught. You remember that we have considered that there are two different states, psi A, psi B, which are having the same energy. Then the linear combination of psi A, psi B is equal to psi naught. That is, psi naught is equal to alpha psi A plus beta psi B. So this is the expression we have to take into the consideration. This is the superposition. Now you substitute here psi naught. You replace psi naught by alpha psi a plus alpha psi b. This one for this psi naught is replaced this by this one, both right hand side and left hand side. Psi naught is replaced by. Now if you just expand this, uh, the alpha is a number, so you can take out. First, you take the inner product with alpha psi a. Alpha can be taken out, so this will become first term will become psi a h prime psi a. Then regarding second term, beta can be taken out because it's a constant. So naturally, this will be psi a h prime psi b. So right hand side. If you come to left hand side, because E1 is a constant, we have already taken it out. And similarly, alpha is constant. Yeah, that also taken away from this. So the inner product with the first term will become psi A with psi A. which is equal to 1. So this will become E1 alpha. First term will become E1 alpha. Naturally, the second term, which is E1 beta times psi inner product of psi A with psi P, due to orthogonal property, this will become 0. So ultimately, you will end up with the expression alpha psi A H prime psi A plus beta psi A H prime psi B, which is equal to E1 alpha or alpha times E1. We have just now seen that alpha psi A H prime psi A plus beta psi A H prime psi B is equal to E1 alpha. Now we will substitute this one by WAA. WAA represents the uh, expectation value of H prime with respect to A psi A. So this will be psi A. Similarly, the other one, this can be written as WAP. Of course, you have alpha and beta, which are the expansion coefficient. So this can be written as beta WAP, which is equal to E1 times alpha minus alpha WAA. That is, I have brought this into right hand side. Uh, I will let you know why I have done so. Similarly, if you take inner product with the psi p, using the same procedure, naturally you will get alpha times WPA in the right hand side because you have the only the H prime term. So you cannot take it out because it's an operator. You don't know what you will get if you operate on the get vector. So this can be written as alpha WPA plus beta WPP. Applying the same rule, you will get plus E1 beta because you are taking inner product with psi of p, for which psi of p expansion coefficient is beta. So naturally you will get E1 times beta. So now you multiply this equation, this one, multiply this equation by WAP. So this will become WAP, WPA plus beta WAP. Here one alpha is the beta WAP, WPP, which is equal to E1 beta WAP, because both side I am multiplying with beta WAP. So now if you bring this to left hand side, you can take as a common. Here also one beta WAP, here also beta WAP. So you can take out as a common. Then it will become WPP, which is minus E1, which is equal to 0. We will see what will happen to this expression. Just now we have seen that alpha WAP plus WAP into WPA plus beta WAP into WPP minus E1, which is equal to 0. Here what we are going to do is, instead of beta WAP, we are going to use this E minus E1 alpha minus alpha WAA in order to eliminate beta. So this also just now we have seen beta WAP is equal to E1 alpha minus alpha WAA. This will be just to you substitute this here. What I have done it here. So E1 alpha alpha WAA. In all these term you have alpha, so I am taking alpha outside. Then remaining term will be WAP, WPA, WAP, WPA. Here E1, because I have taken alpha as common, minus WAA into WPP minus E1. uh, let us say alpha is not zero, non-zero quantity, then you can take out alpha, you will get WAP plus WPA plus E1 minus WAA, WPP minus E1, which is equal to 0. Just simple mathematics, arithmetic. So you just to multiply this thing, you will get WAP, WPA plus minus E1 square, because here E1 minus here plus E1 minus E1. This will become minus E1 square. And if you multiply this E1 with WPP, E1 WPP, similarly, this minus WAA minus WAA WPP, the second term, third term, and WAA minus E1 which will become plus E1 WAA, which is equal to 0. This is a simple mathematical step. So we will see what we have. So we have arrived with this final expression. Uh, just you rearrange the terms. It's a very simple mathematics, so I need not explain. By simply rearranging this term, you will get minus E1 squared. Then take E1 terms. E1 here in two places there are E1 appears here and here E1 appears. So this can be taken E1 WAA here and WPP. So we have taken E1 WAA plus WPP. Similarly, all other constant term you bring this, not a constant term, all other W you bring this, because it's an operator. You know meaning of WAA. WAA is psi of A, H prime psi of A. So likewise, so you know the definition of this. So this will become minus WAA WPP, this one, this term, and plus this one, first term, WAP plus WPA, which is equal to 0. So this can be multiplied by minus 1, so you will get E1 squared minus E1 WAA plus WPP plus WAA WPP minus WAP WPA, which is equal to 0. This is nothing but our quadratic equation, for which solution you know x is equal to minus p plus or minus square root of p squared minus 4ac. Here a, naturally the coefficient of e1 squared term is 1, a is 1, so it is 2a will become simply 2. Then the term p, this one, coefficient of E1, that is WAA plus WPP. So this is minus P. You will get minus P. And C is this entire term is C. 1 minute. This entire term is sorry. This entire term is C. This is C. So this is a very simple mathematics. You substitute this here 4a c, actually it will become just 4c, because a is equal to 1. And also, I like to highlight one important point. WAP is equal to WPA is equal to complex conjugate of WAP. So naturally, this can be written as WAP modulus of WAP squared. This red color rectangular parts can be written as WAP modulus of WAP squared, because both are complex conjugate. You got to remember that WAP is, WAP is bra A H prime get P. WPA is bra P get H prime get psi. So it's a complex conjugation. is an operator. You got to remember H prime operator. If you operate on the wave function A and P, which with H prime, P and A with H prime, so you will get a solution. After some mathematical step, it's a very simple step. I have not done it here, so you can do it in a very easy manner and rearrange the term. You will get E1 plus or minus is equal to half WAA plus WPP plus or minus square root of WAA minus WPP whole squared plus 4 modulus squared WAP. This plus or minus indicate here there is a plus or minus. So there are two solutions. One is with plus, other one is with minus. Finally, we have seen that E1 plus or minus is equal to 1 over 2 WAA plus WPP plus or minus the square root of WAA minus WPP whole square plus 4 modulus WAP whole square. This is the solution. We have two solutions because plus one solution and minus one solution. Because it's a two-fold degeneracy, we will have two solution. Uh, if, let us say alpha is equal to 0 and beta is equal to 1. You know very well WAA is nothing but psi of A H prime get psi of A. Similarly, this is psi of P H prime get psi of P. Similarly, AB is uh, cross psi of A H prime get psi P, and WPA is equal to psi P H prime get psi A. So this is the meaning of this W. Since alpha is 0, uh, psi of A, coefficient for psi of A is equal to 0. Then WA term will become 0. So this will be 0. This is PP. And here WAA again 0. WPP exists and WAP also will become 0. So totally this will be WPP whole square. So if you take square root, this will pick up WPP. So 2 WPP. So here there is 2. So this will become WPP. So E1 will be equal to uh, WPP. That is pra psi P H prime get psi P. So this is for E1. Similarly, uh, for alpha is equal to 1, beta equal to 0, the all p term will go to 0. We will get E1 is equal to psi A H prime psi A get psi A because uh, alpha here alpha is 1, alpha is a coefficient for psi A, so naturally only the psi A term exists, other term will cancel out. So if you look into the two expression, it is exactly equal to the first order perturbation theory for non-degenerate case, because we assume one of the coefficient is equal to 0 there. That means only one state is allowed. So naturally, E1 is the expectation value of H prime on the get psi p. Similarly, uh, it is here it is expectation value of H prime on psi a basis. So this is the very interesting result about this thing. That is either if alpha is equal to 0 or beta is equal to 0, only one energy level exists. Uh, Thank you very much for watching my video and supporting me. Uh, this is about the degeneracy case. Thanks to all.